വെൽക്കം ടു മൾട്ടി ട്രേഡ്സ്. എല്ലാവരും സുഖമായിട്ടിരിക്കുന്നോ? ഇന്ന് നമ്മൾ പഠിക്കാൻ പോകുന്നത് ചാപ്റ്റർ 3 ആറ്റംസ് ആൻഡ് മോളിക്യൂൾസ്. ഐ എം സോ എക്സൈറ്റഡ് ടു ബി വിത്ത് യു ദിസ് മോർണിംഗ്. യു നോ വാട്ട്, ആറ്റംസ് ആൻഡ് മോളിക്യൂൾസ് എന്ന് പറയുന്നതാണ് വെരി ബേസിക് ഇൻ കെമിസ്ട്രി. ഇത് മനസ്സിലാക്കി കഴിഞ്ഞാൽ കെമിസ്ട്രി ബിക്കം വെരി വെരി സിമ്പിൾ. നിങ്ങൾക്ക് ഫോർമുലാസും ഇക്വേഷൻസും ഒക്കെ എഴുതാനായിട്ടും പിന്നെ മോൾ കോൺസെപ്റ്റ് മനസ്സിലാക്കുവാൻ ഈ ചാപ്റ്റർ വളരെ വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. സോ മേക്ക് ഷുവർ യു വാച്ച് ഇറ്റ് കെയർഫുള്ളി. മേക്ക് ഷുവർ യു ഗ്രാബ് യുവർ ടെക്സ്റ്റ് ബുക്ക്. Make sure you grab your notebook and pen. Okay, so that when we go through it, you can write it down. Again, if you don't understand something, please let me know by just commenting, and also you can give me a thumbs up if you like. And if you don't like a thumbs up, you can do a thumbs down. But make sure you write the reason for giving me a thumbs down, so I can see that something that you didn't understand, so I can help you out. All right. Again, if you find this lesson useful, please make sure to share it with your friends, with your cousins, and let's all support each other at this time of pandemic. And let's get a strong understanding of the concept of atoms, molecules. Again, atoms and molecules, I've already taught them in a previous lesson. If you don't understand the basics, you can watch those videos, and I'll give you a link in the description box below for those videos. But I'm going to go through chapter 3 in your textbook, Atoms and Molecules. So grab your textbook, pause the video, grab the textbook, grab the exercise book or your notebook, and take notes as we go through it. Okay, so let's get started. So the first one is law of conservation of mass. Now, law of conservation of mass states that mass can neither be created nor be destroyed in a chemical reaction. Okay, so mass can neither be created, so we cannot create it, or we cannot destroy it. Okay, but then what happens to it? It is changing its form. Okay, so for example, you have given on the first page 3.1.1, here it says there are 3 activities: copper sulfate with the sodium carbonate, barium chloride with sodium sulfate, lead nitrate with the sodium chloride. So when we start with copper sulfate and sodium carbonate, they have given you how much we are adding there in each conical flask. So 1.25 grams of copper sulfate is mixed with 1.43 grams of sodium carbonate, and we know that the products are sodium sulfate and copper carbonate. Now you might wonder, how did I get that? Now that's what we are going to learn after a few minutes, how to write chemical formulas and also how to write chemical equations. All right, so don't worry about it. So let's see. Now if you are starting with 1.25 grams and 1.43 grams, for example, so 1.25 plus 1.43, so what's the total? 5 plus 3 is 8, 2 plus 4 is 6, 1 plus 1. So we have a total of 2.68 grams on the reactant side. Okay, so reactants react to form products. Here altogether you have 2.68 grams. At the end, you must have 2.68 grams at the end. So let's look at the first example that's given to you in your textbook, copper sulfate. So copper sulfate Cu2 plus. So we will learn more about ions, anions and cations. So for just now, for the time being, you just listen to me. So we are going to learn how you can write all these formulas. Okay, so don't panic, just patiently listen. So copper sulfate plus sodium carbonate, when they react, so these are the reactants: reaction 1, reaction 2, reactant 1, reactant 2. 2 reactants, when they react, what are the products we are getting? So we need to write products on this side. Because of the space, I'm going to write it here. Okay, so you get copper carbonate, so CuCO3 plus Na2 SO4. Okay, sodium sulfate. Now if I have reactant 1 1.25 grams and then reactant 2 1.43 grams, and if this happens in a closed container, what do you mean by closed container? For example, let's say this is my conical flask, and if I have a cork here, that means it will not allow the reactants or the products to escape into the atmosphere. Also, it will not allow any gas from the atmosphere to go into the conical flask. Clear? So we have only copper sulfate, sodium carbonate. We added those two and put the cork in, and then what happened? You got copper carbonate and sodium sulfate. So if the matter is not escaped, then what happens? You must have the same mass on the product side. So that is why it is called law of conservation of mass. So energy or the mass can neither be created nor be destroyed in a chemical reaction. It has to change from one form to another. So here it was copper sulfate, but here it is copper carbonate. And sodium carbonate becomes sodium sulfate. So it has changed its form, but it hasn't been destroyed. You have the same number on either side. Now this is not a balanced chemical equation. We will learn more about balancing. We will learn about how to write chemical equations in our classes. But this is just to help you understand the law of conservation of mass. Clear enough? So law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Now certain things we need to keep in mind, that the reaction must happen in a closed system or a closed container. If it is an open container, let's say if it is open, then what happens? Gases can escape, other gases can come in. That means instead of these, there might be something else along with that. So when you weigh it, what happens? The electronic balance, instead of 2.68, it might show 3.5 grams. Do you understand? Sorry, in this one, and this should be 2.68. This sometimes 3.5, or it could also show 2.2 grams. Clear? Because we can see that it's an open system. It has not been closed tightly or closed properly, or it has not been closed. So is that clear to you now? All right, so that's all in this one. Let's look at the question that's given. Question number 1. In a reaction, 5.3 grams of sodium carbonate reacted with the 6 grams of acetic acid. Okay, so again, we have now 5.3 plus 6 grams. So what is 5.3 plus 6? 6 plus 5 is 6 plus 4 is 10. So 11.3 grams on which side? Reactant side. The products were 2.2 grams of carbon dioxide, 0.9 grams of water, and 8.2 grams of sodium acetate. So what are the products? We have 3 products and 2 reactants. So when we add all the products, we need to see whether we are getting 11.3. So 2.2 plus 8.2. 8 plus 2 is 10. So 10 plus 4. 10.4 plus 0.9. So that is 11.3. So on both sides of the arrow, on both sides, you have 11.3. So what does that mean? The mass hasn't been escaped. Now about atoms, about atomic mass, about molar mass, we have already learned that in a previous lesson. I will give you the link in the description box below. But now we are going to go through how to write the chemical formula. For that, we need to have some understanding of the periodic table. Now, first of all, we know these are all elements. So this is a periodic table, of elements. And this is group 1, this is group 2. We call this as group 3, 4, 5, 6, 7, 8. Okay. So I'll just write 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so first group, they are metals. Metals are highly, these alkali metals are very, very reactive. For example, sodium. The moment you put sodium in water, it just explodes. Okay, very interesting reaction. If you look for some YouTube video, sodium plus water, you can see very explosive reactions. Similarly with the potassium and water. Okay, very, very interesting. Again, calcium with water, they are again reacting. So we can see that these metals are very, very reactive. So what does that mean? For example, when we learn about valency, so for example, lithium has 2 electrons in the inner shell and 1 electron in the outer shell, lithium. Sodium has again 1 electron in the outermost shell. Okay, so group 1, all of them have 1 electron in the outermost shell. And to become stable, what do you mean by stable? Stable means it has 8 electrons in the outermost shell. Now, to become stable, sodium must get how many electrons, or lithium must get how many electrons? Another 7. Okay? Or, so is it easy for lithium to grab another 7 to become stable, or is it easy to get rid of this 1 electron to some, or give it away? Which is easier, to take or give? Definitely we know, because it has to gain 7 electrons, it is better to give that 1 electron away, right? So what they do, lithium loses that 1 electron and it becomes lithium plus. Now, why we give lithium a positive sign? We know that the number of protons is equal to number of electrons, correct? How many electrons lithium had? Earlier, it had 3. That means it has 3 protons. So the number is balanced. But now, lithium has lost 1 electron. So it has now how many electrons? Only 2. So what is the majority sign here? They are positive. So that gives lithium that positive sign. So lithium has lost 1 electron, and that means majority is positive here. So that is why it is positive. There is nothing to balance that 1 electron, 1 positive with another electron. Okay. Now if you look at sodium, it's the same thing. Those first group elements, all of them have 1 electron in the outermost shell. That's why they are very reactive. They want to get rid of that somehow so that they can become stable. Now when I say get rid of it, what happens is they are going to give that electron to someone. For example, sodium. Let's say sodium. Sodium can, again, 1 electron, when it loses that, it becomes Na plus 1, or you can also write plus. Doesn't need that 1 because plus means it has lost 1 electron. And chloride, which is in group 7, has got, let's say, chloride. I'm not going to draw all the shells. I'm just looking at the outermost shell. It has got 7 electrons. 1, 2, 3, 4, 5, 6, 7. Chlorine actually needs just 1 more, 1 electron to become stable. So what they do, they take that 1 electron from sodium, and what happens? It becomes sodium chloride. That is our salt or table salt. Okay. Group 2 has got 2 electrons in the outermost shell. That is why if you look here, this group 2 has got 2 electrons to donate. Group 6 has got 8 electrons. So the first two go into the first shell, and then it has got how many electrons in this second? 1, 2, 3, 4, 5, 6. How many more they need? Is it easy to give away, or is it easy to grab another 2 to become stable? It is easy to grab 2. So that's why group 6 has got -2 or 2 minus. Can you see that? Next comes group 7. Group 7 has got 7 electrons in the outermost shell. That means it needs 1 more to become stable. Can you see F minus? So let me recap. Group 1 will donate 1 electron because It's easier for them to give away than take. Group 2 also do the same. They will give 2 electrons. Group 6, it is better for them to grab 2. Group 7, easy to grab 1. What about group 8? They are already stable. Can you see 2, 10, 18? They are already stable. They don't need any either to give or take. They are already stable. That's why helium, helium, we put helium in balloons, or they are very inert. So the term I used is inert. Inert means they do not react. They do not react. Okay, they are already stable. All right. So you might wonder what happens group 3. Group 3 can also donate 3 electrons because it is easier to give 3 than to grab another 5. Groups 4 has got equal chance. They can give or take. Mostly they undergo sharing of electrons. Group 5, it's better for them to grab another 3. Does that make sense? So group 1, getting rid of. So when they remove that electron or when they lose electron, they become ions. So they are called ions. So what are they called? Ions. An element has all of their electrons with them, and when it becomes an ion, it becomes an ion when they lose or gain an electron. When they lose an electron or gain an electron, we call it as anion and cation. Now cations are positively charged, anions are negatively charged. So in this case, sodium, is it an anion or a cation? It is a cation because it's positively charged. Think about cat with that positive sign on the middle, cat. Anion, N, negative, yeah. So chloride is Cl minus 1 because they have already taken 1. Clear enough? So that's how you find whether they are ions or not. So ions are atoms that they have lost an electron or they have gained an electron. Clear enough? Alright, so now let's look in your textbook. You have the table 3.6, names and symbols of some ions. So if you know the basics of this, in a periodic table, you can easily find out whether they become a positively charged ion or a negatively charged ion. So you got some symbols and name of ion, name of metallic element, all those is given. And again, the other thing is that when non-metals like a chlorine becomes chloride. So if you look at the name, it is chlorine, oxygen, chlorine, fluorine, sulfur. Okay, but when it becomes their ion, it changes the name to IDE at the end. So bromine become bromide, chlorine becomes chloride. So CHLORINE, chlorine become chloride. So for example, sodium, you might have noticed I didn't say sodium chlorine, I said sodium chloride. The other thing we need to remember, always metal goes first. Metals first, non-metals second. So metals first, non-metals second. Okay. Now you can also see some polyatomic ions. Now these ones, you make sure you understand. So ammonium is NH4 with a positive, means +1. It has lost 1 electron. Hydroxide means it has gained 1 electron. Nitrate means it has gained 1 electron because NO3 -1. Carbonate again gained 1 electron. Carbonate, it has gained 2 electrons. Sulfite gained 2 electrons. Sulfate gained 2 electron. Phosphate gained 3 electron. So you just need to understand that. Now I am going to teach you how to write the formula of simple compounds. So we are going to learn how to write the formula of simple compounds. So I will stop at here and you can listen to my next video, part 2. Okay, so chapter 3, atoms and molecules, how to write the formula of compounds, simple compounds because that again it needs a bit more understanding. I hope this is clear to you. As I said earlier, please share it with your friends. Give me a thumbs up. Give me a message saying how you understood, whether you understood this lesson, whether I was too fast, whether it was clear to you, whether it is helpful to you. I would love to hear from you guys. Okay, thank you.